I am not exaggerating when I say that Mario 64's sound engine is absolutely insane. Look at this Tetris gameplay. What if I told you that the entire game of Tetris is simply a Mario 64 sound effect that DevWizard composed? And what you're seeing right now is running as a sound effect inside Mario 64. In fact, all I've done to this version of Mario 64 is replace Bob-omb Battlefield's music with DevWizard's music. Recently, I wanted to cut out unnecessary stuff from the Mario 64 sound engine to improve the performance of my mod, return to Yoshi's Island, and while a fool gets rid of things he sees no use for, the wise man first finds out what a thing's use is, to then deliberate whether it's actually needed or not. The original engine was over 10,000 lines of code, which is simply way too much for what it does. This means I've recently read and understood the entire Mario 64 sound engine, and in doing so, I found quite a few interesting things to add to the iceberg, as well as some things that we will demystify. Have you ever felt your cartridge was haunted because of this low-pitched boot-off sound effect that plays randomly when you enter the mansion?
Whoa, what the f***? Yo, what? Did anyone just hear that?
And did you know that Mario 64's audio runs at 240 frames a second, 8 times higher than the game itself? And what if every sound effect that ever plays in the game is simply part of one big MIDI-like formatted song that is being composed by the game itself while the game is playing? When they programmed the audio engine for Mario 64, they likely planned far ahead. A format similar to Mario 64's audio format was also used in Ocarina of Time, Majora's Mask, Star Fox, and, well, pretty much every other first-party Nintendo 64 game. The sound bank format used in Mario 64 is also used universally across literally every official N64 game ever made. Which is why N64 Sound Tool, just one single application, can edit pretty much every N64 game's audio at the same time. These were created with the instrument compiler. This tool was so ingrained into the N64 development culture that the documentation for the console explicitly mentions this software. Although no part of the hardware necessitated this tool, and the homebrew community nowadays even has other alternatives. It seems like they wanted to cover every use case possible in Mario 64 sound engine. I believe they planned for every future title to rely on it. This engine's crazy feature set was barely used in Mario 64 though. Mario 64's dynamic features are limited to fading in individual channels, for example in the caves in Jolly Roger Bay, where the drums are audible only while you are inside this cave here. But it was capable of so much more, and that's what we will explore today. Before we can understand the full feature set, we need to understand one special feature: how sound effects are intended to work in Mario 64. Mario 64 sound effect used the exact same playback code as its music. We will call this code the sequence processor. Mario 64 can play up to 3 of those sequences at the same time: the level music, special jingles like a race fanfare or the Toad Talk music, and the last sequence is sound effects. Basically, Mario 64 has a sequence file playing at all times on top of the background level music that is dynamically being edited to update the channels to have instruments that match the sound effect audio files and notes that match those sound effects pitches. The game will signalize to a sound effects manager that it wants to play back a sound effect. The sound effects manager then picks the highest priority sound effects that were requested in this frame for all 10 active sound effect channels and writes the result back to the sound processor's I/O channels. The result will be a singular number which will signalize which sound effect should be played. In the background, the sequence processor runs the sound effect sequence at 120 BPM, 4 times the in-game frame rate. This is not important right now, but we will come back to this because it leads to a couple crazy edge cases. But what even is a sound effect? Naively, you may assume it is an audio file being played back. But remember, the system really just dynamically edits a big sequence file.
Thank you so much for playing my game.
So a sound effect is actually an entire composed single channel music sequence that will play back as one channel of the sound effect sequence via the sequence processor. So for example, the change from noise here is multiple audio settings comments and even 3 whole notes with portamento applied. This way, interestingly, sound effect playback respects things such as the volume or panning or even the tempo of the sound effect sequence, which can be edited for humorous effect. In this footage, I've edited the vibrato, pitch and tempo of the sound effect sequence, and it's pretty funny. Now, it is actually extremely important that the game allows the game creators to compose sound effects like that. Sound effects are massive to store. Even in this compressed format, they are about 26.5% of Mario 64's storage size. The game could not have been made without this technique. Letting composers remake sound effects is a great way to save precious cartridge space over having to store more sound effects. Almost all sound effects in Mario 64 are composed of simpler sounds to get complex outcomes. This means stuff like the camera sound and the coin sounds share an instrument, even though personally I absolutely cannot hear the similarity between those two sounds. Here's what the unremixed sound sounds like if you're curious. But even less obvious examples exist. Something like Mario's landing sounds or multiple footsteps, and even Goomba alerts. Actually pretty much any sound effect you can name is composed of multiple smaller notes, and this saved a great deal of memory. But do you know what you should not cheap out on? Your chair. If you're like me and sit upwards of 14 hours a day in your computer chair, having a good chair might be a worthwhile investment. This is my Ranzat old chair, and I didn't even realize how much of an issue this was in my life until Flexispot sent me their C7M adjustable chair. This chair has nice lower back support and an adjustable headrest, which makes my back feel so much better. Building this chair is kinda like playing with Legos, just a lot more useful. They don't want you to notice, but I actually homebrewed my chair by removing the armrest because I like to sit very weird. Of course, the armrest is fully adjustable. It is a great armrest. I simply prefer not to use it. Flexispot is super confident you'll enjoy the chair just like I do. So they offer a 30-day, no questions asked, money back guarantee and 10 whole years of free replacement chairs. And if you're on a budget, you can check out their C5 chair with most of the same functionality. Or you could check out their C7 Morpher, which has even more features than the chair they sent me. Use my code C730 to get $30 off in the description to get the best price. But not just remixes had to be handled. Now we get to the really interesting stuff. Things like the red coins that increase in pitch as they play had to function too. There are many ways to make this work, but Nintendo opted for the most insane way. The sound effect file has self-modifying code that uses the sound effect ID to edit its own pitch shifting comment appropriately. I'm going to assume most people have trouble reading this red coin program, so let me explain. First, a sound effect ID is passed to the sound processor that's increased by 1 for each red coin you've collected. Then, 8 identical pointers to red coin sounds are part of the playback table. This ensures all 8 red coins play back the same sound file. And now the self-modifying part. The game plays back the red coin music, which is actually kind of a program, which subtracts hex 28 from the sound effect ID and uses that to read from the major scale, and then uses the self-modifying write sequence comment to override the pitch shift comment with the value here. And that's actually already all that was needed. Similar self-modifying code exists to implement room echo, the secrets pitching up, and birds. For some reason, I don't get why, but it exists. There are a couple noteworthy composed sound effects made out of other instruments. I'm using the word instrument liberally here, game code wise. So for example, the boo laugh is an instrument that can be played at a lower pitch to get a Bowser laugh. The Bowser laugh fact is actually very famous, and I bet you already knew that. But it goes much deeper than that. How many characters do you think Charles Martinet voiced in Super Mario 64? Just Mario? No, way more. Maybe you've heard of the sound effects library Charles Martinet recorded that Nintendo used on Mario 64. These were used for Bowser, the Bulov, and apparently even for Thwomp and the Womp. But that's still not the full list of characters he voiced. Mario's voice clips are actually being remixed for both the pink talking Bob-Ombs and also for the Chuckya death sounds. Personally, I cannot hear these out at all, but from the code I 100% know they are there. This means Charles Martinet actually voiced 6 characters in this game. But even that's not all. The thwomp sounds were also used for King Bob-omb, the Bully, the Chili Chief, and even the IROC, making a total of 10 characters Charles voiced in Super Mario 64. This is a great way to save precious cartridge space. Audio is actually massive to store. In my own game, the ROM file is over 80% audio data. Speaking of the Boo Loth, you may have heard this creepy Loth randomly play sometimes in Big Boo's haunt. It happens extremely rarely, and seemingly every couple years a new clip of it happening goes viral. But why does it happen? It's actually the wind. The wind sound effect is weird. It only plays while you're outside of the Boo mansion and stops the moment you enter. It has multiple layers of instruments and notes that play at the same time. It first has wind sounds via bank 5, instrument 6, and then the Boo sound via bank 6, instrument 9. Okay, so what is the Boo Loth instrument doing here? Let's start simple. This sound has 2 layers. First, there's a layer something on comment. This comment turns on continuous note, which means any subsequent note on this layer does not restart playback and thus does not grab any newly set up instrument. This layer starts playback immediately, and because of that, it permanently grabs the wind sound effect. The second layer does not have that flag. Instead, it is a bunch of notes that pan from different direction. This layer has a 1-frame delay at the start, matching the delay until the Boo instrument gets set up. This layer is actually what plays the creepy Boo Loth all over the place while you are in the level. When you exit the outside area, by entering the door, the play sound function stops being called. For continuous notes like this, the game waits 2 frames before it then fully disables the sound. When this happens, the first layer seems to somehow get out of the continuous note state and ends up playing the currently set up instrument, the Boo Loth, on the first layer with a much lower pitched noise. To be entirely honest, I don't know why this bug happens. Instead of fixing it, I've simply rewrote the engine, but knowing that this is just a silly bug, maybe we've made the game just a little bit less scary. This intricate sound playback system lets you do some very cool things. One of my personal favorites is this credits theme remix Sauron made. In this level here, you revisit all the levels from Mario 64 in one big stage. As you progress, the sequence dynamically changes itself to fit the level that you're currently platforming in. It even has a special jingle if you skip a section or if you fall down. Neat bonus Sauron added, right? Well, actually, that jingle is a technical limitation. Let me explain. Usually a sequence in this tracker format can only have 16 channels, but there are 8 versions with multiple channels in each, so we would be far beyond the 16 limit. That means we can't keep track of where each channel along the playback it is, unless we added new functionality to the engine and wasted a lot of resources. That's why we do a smart trick. The sequence has multiple synchronization points at which the next part's sequence starts playing. This way, only 2 out of 8 themes are running at a time, with one of the 2 being silent until the transition happens and the next song takes over. But that does mean that if you skip a section or you fall down, we don't have a sequence in a ready state. How fortunate that we have a nice jingle for falling down or skipping a section to cover this fact up. Limitations forced us to get creative here. Of course, just like before, this all works via the sound scripting system. The game actually only tells the sound engine which section Mario currently is in. The sequence here, by itself, uses the scripting language in the sound engine to handle all the functionality. I think this is exactly the type of thing the sound engineers had in mind when they first wrote such an intricate engine. I bet that seeing this made one old programmer in Nintendo jump in joy. This is the ultimate usage for it. The sound I/O system is essentially an entire programming language, although a very simplistic one with only a few commands. There are commands to read or write bytes from the I/O channels, commands to store bytes, and commands for subtractions, as well as logic instructions to jump around the program, but some really simple stuff like an addition or a bit shift command does not exist. In a way, it's very close to programming languages like brainfuck. Technically it can do a lot, but doing anything with it is kind of unreasonable. Although people like Portal Runner have programmed Snake in Brainfuck before, with his code looking like this. This is also what allowed Dev Wizard to program the entirety of Tetris into a sound effect. Dev used the format not to program inside itself, but rather to manipulate memory to allow for a remote code exploit that allowed him to execute any payload. In this case, the entire game of Snake. This works kind of similar to how certain types of malicious attacks would work, except it's used for cool purposes right here. Technically, the music script is Turing complete, so you could program Tetris or pretty much any possible program entirely without needing to jailbreak out of the code like that. Moving data, logic and elemental math is really all you need for that, but that would be quite a pain. Now unfortunately, I have to say that some of this complexity was lost in my complete rewrite of the engine for the sake of memory and performance. We simply don't need a fully functional programming language in the music format to play music. My rewrite actually reduced the size of the sound engine from 56 kilobytes down to just under 12 kilobytes. But that is it for this video. Shoutouts to all my Patreons. If you have suggestions for what else you would like to learn about the Maori 64 source code, let me know. I'm currently working towards replacing every last line of Nintendo code in Mario 64, so I can say that I have my own fully custom engine. At that point, even if they did legally threaten the project, I would simply pivot to my own IP. So far, this yielded great memory and performance benefits, and there are tons of things I could talk about. See you guys in the next video. Bye bye!